Hello everyone, welcome. Today we are going to generate three-phase sine signals using analog electronics. Later we will use these signals to produce SPWM. Uh, so let's dive into the details in this circuit. You can see RC phase shift oscillator fundamentals output frequency 15 Hz. You can calculate the frequency thanks to the given formula. You can see this formula. You can calculate value R and C, and so you can see this section. You can see the RC phase shift oscillator where we generate our fundamental sine wave output, uh, input input the RC phase shift. Over here we have the RC phase shift system. Over here you can see we have the RC phase shift system used to obtain 220 degree and 120 degree and 240 degree for phase shifting, a fundamental signal. Each RC section provides a 40 degree phase shift. Uh, this R and these resistors and these capacitors provide 40 degree phase shift, and totally 1 2 3 RC section uh, give you totally 120 degree phase shift. As a result, at the end of 3 RC stages we get 120 degree, and at this point end of 60 RC stages we get 240 degree phase shift. You can verify this phase shift using the formula shown here. So then, in order to equalize the amplitudes of the three sine signals we obtained, we use a voltage divider. You can see one uh, one phase, two phase, three phase, and a non-inverting op-amp configuration. You can use voltage divider and non-inverting op-amp configuration, and you recalculate your amplitude of the fundamental sine wave thanks to the using trimpots. Now let's move on to the simulation and examine our signals. Before starting oscillator, no, you can see three-phase sine signal and some equal amplitude. We will adjust the trimpots a little and check the results. And before before voltage divider Trimpots adjust, and you can see yellow signal, sine signal amplitude get increase, and adjust the same level, and you can adjust the 120 phase shift signals amplitude. Yes, start the simulation. You can this formula for amplitude output signals in the following respectively like this. We check the fundamental sine frequency, resimulate, start to simulate oscillator, starting oscillator. Now we check the fundamental frequency there. You can see 15, 2 and 1 fundamentals frequency. We can adjust this frequency thanks to the R1 resistors, and but oscillator stopping. No, you can see this there. You can see 15. Okay, maybe enough. Stay tuned for more, and thank you all. Goodbye.